Hello everyone. Today in this video I am going to speak about the capacitor filter circuit. The previous video which we recorded has the previous video which we recorded has the concepts of rectifiers, half-wave rectifiers and full-wave rectifiers. Now before going into the capacitor filter circuit, the rectifier is a circuit where we can expect the input to be AC component and the output to be DC. But in practical, we cannot expect the pure DC. So whatever the DC output we are getting, we say it as a pulsating DC rather than a pure DC. Now, in order to convert this into a pure DC, we require some circuit where this is going to convert the pulsating DC output from the rectifier into a pure DC. Now we already know from the rectifiers which we have studied, and which is available in the previous video also, which says that there is a presence of a ripple even in the case of half wave rectifier as well as in the case of full wave rectifier. We know what is a ripple. Ripple is nothing but some amount of AC component which is present in the DC output of the rectifier. We call it as a ripple, right? So whatever the ripples that is present in the DC component at the output of the rectifier is going to be removed and we get the pure DC. In order to perform this, we are going to have a circuit which we call it as filter. Now, what is a filter? A filter is a circuit where actually it is going to convert or it is going to remove the AC component which is present in the DC output of the rectifier. You can look into the block diagram where actually for the rectifier, block diagram shown here shows that for the rectifier we are giving AC as the input supply. After that, once it comes inside the rectifier, we know rectifier is going to convert this into DC component, which is not a pure DC again. It is a pulsating DC where some amount of AC component, which we call it as ripples, are going to be present at the output of the rectifier. So we are going to incorporate a filter circuit across the output of the rectifier in order to filter the AC component that is coming in the DC component of the output of rectifier. So there are many kinds of filter circuit, out of which we are going to study capacitor filter. Now when we look into the capacitor filter, remember always the filter circuit has to be connected after the rectifiers but not before the rectifier. So after the rectifier we are going to connect one capacitor where, and after that capacitor we are going to tap the output across the load resistor RL. So now whatever the pulsating DC is now fed as input to the capacitor, and across the load resistor we are going to get the pure DC, that is because of the capacitor filter. So this speaks about the working principle of capacitor filter circuit. Now let us move on to the working principle, that is construction of a filter circuit, capacitor filter is done. Now let us study the working principle of capacitor filter circuit that is connected for the rectifier. Now before going into the working principle, no matter whether it could be a half-wave rectifier or whether it could be a full-wave rectifier, we have to connect the capacitor filter circuit or any other kind of circuit where we can convert the pulsating DC into AC. So if I take a half wave rectifier, let it be a secondary winding. I have a diode here. So soon after this diode, I should see to that I should connect a capacitor over here and then a load resistor RL. So this is my RL and this becomes my C. So this tells that once the diode is going to convert it into DC, once the AC is getting converted into DC, I can say my capacitor is going to act as a filter and which is going to remove the DC that is pulsating DC and or remove the AC component that is going to be present in the DC output of the rectifier and into a pure DC which is tapped across the output load resistor RL and which is shown here. Now you can look into the output of the capacitor. Yes, you can look into the output with capacitor. So when you look at, you have the waveform getting converted. So this is with respect to which waveform? This is with the half wave rectifier. So for the positive half cycle it is conducting and for the negative half cycle it is not conducting. Similarly for the positive half cycle it is conducting, negative half cycle not conducting. Right? Now whenever I incorporate a capacitor for the as a filter circuit, I can see there is a charging and discharging action. Whenever we see the capacitor, we know that the capacitor is going to charge and discharge, right? So there is a charging and discharging action happening with respect to the capacitor filter, then only I can expect a pure DC. Now let us look into the working principle. How actually this is going to work. When we look into this, you can have a look here. Whenever the voltage across the output of the rectifier, right? The voltage across the output of the rectifier, that is a pulsating DC, which I am going to call it as, let it be VR. Whenever the voltage across the output of the rectifier is greater than V naught equal to Vc, where V naught is my output voltage and Vc is my capacitance voltage. So whenever my rectifier output is going to be more when compared to the V naught equal to Vc, then my capacitor is going to charge. Yes, my capacitor is going to charge. Till what period it is going to charge? Look here. So this period we call it as a charging period. So this is my capacitor is charging here. Till what period it is charging? Till the period T1, right? So this is my charging of capacitor. Now till time T1 it is going to charge. Now after T1 I can observe my waveform is deteriorating, right? So as a result, what is happening here? I can say my rectifier output VR, whenever my rectifier output VR becomes less than V naught equal to Vc, I can say my capacitor is now in the discharging condition. So this is where my capacitor is going to discharge. Okay, now where do we tap the load? Where do we tap the output? Across the load. So I can say now, since there is a action of charging and discharging of capacitor, I can say the ripples can be removed, right? So this is about the working principle of capacitor filter circuit, which is connected for the half wave rectifier, right? So for any kind of rectifiers, at the output of the rectifier, we expect a filter circuit, whether it could be a capacitor filter circuit or any other kind of filter circuit. It is expected to connect the capacitor, not only capacitor, it is expected to have a filter circuit across it, right? Now, knowing the concept of the working principle or the working principle of capacitor filter, let us look into the ripple factor when we incorporate the capacitor filter, right? For the half wave rectifier, the ripple factor is given by R is equal to 1 by 2 into root 3 F into RLC, where F represents the frequency, RL represents the load resistor, and C represents the capacitance value. So this is for half wave rectifier. When we go for the full wave rectifier, it is represented as, that is the ripple factor is given by R is equal to 1 by 4 root 3 F into RL into C for a full wave rectifier, right? So this is about the ripple factor when we connect the capacitor filter circuit across the rectifiers. So when we connect a suppose if we have a rectifier like this, and when we calculated previously, what we did is we had a rectifier circuit. For that only we calculated the ripple factor. Now we are calculating the ripple factor after incorporating a filter circuit, right? So once you incorporate the filter circuit, we know it is going to remove some amount of ripples that is present in the DC component and make my pulsating DC as a pure DC, right? So as a result, it is very much needed to calculate the ripple factor once you connect the capacitor filter circuit or the filter circuit to the rectifiers and know the ripple factor with and without the rectifier. So if it is a half-wave rectifier, the ripple is given, a ripple factor calculation is done with the formula R is equal to 1 by 2 root 3 F into RL into C, and for the full wave rectifier it is given by 1 by 4 into root 3 F into RL into C, where F stands for frequency, RL stands for load resistance value, and C stands for the capacitance value, right? Now after this, after ripple factor, it is very much needed to calculate the DC voltage, that is output DC voltage. We know a capacitor is also going to provide the DC voltage, right? So what is the output DC voltage? Output DC voltage is given by VDC is equal to Vm equal minus 1 by 2 volt of ripple, that is AC voltage, okay, where ripple is nothing but my AC. So as a result, I can represent my VDC as equal to Vm minus half into V of ripple, Vm minus half into V of ripple. So this is what this says you, this gives the knowledge on the working principle of capacitor filter and the ripple factor calculation formula for the capacitor filter. I hope this video gives you a knowledge on capacitor filters and its working principle and the formula for ripple factor. Hope this video is beneficial for you. Thank you.